In one of my previous videos, I explained internal resistance of a cell. In this video, I am going to explain measurement of internal resistance of a cell by potentiometer. So this is the circuit diagram. End A of the potentiometer wire is connected to the positive terminal, and the negative of the battery is connected to the end B through a key K1. Then the positive terminal of the cell whose internal resistance is to be measured is connected to the end A. Negative terminal is connected to the galvanometer, then high resistance, then jockey. Across the cell, a resistance box is connected and a key K2. As per the principle of the potentiometer, EMF is proportional to the potential difference across this wire. With this key open condition, you move the jockey along the wire. At one point, galvanometer will show zero deflection. At that time, EMF of the cell will be equal to the potential difference across this wire. Potential difference across this wire is equal to IRL. So EMF is proportional to the length. Now in this case, EMF of the cell is proportional to the balancing length. Let the balancing length be L1 with this key open. Now you introduce some resistance, non-resistance in this box and close this key. There will be a current. That current is given by this relation. Current is equal to potential difference, that is EMF of the cell, psi, divided by total resistance. Capital R is the external resistance and small r is the internal resistance of the cell, that is a total resistance. Then potential difference across this resistance is current multiplied by resistance. Psi divided by R plus R is the current. When current is multiplied by the resistance, is a potential difference. Then you move the now with this key closed, you move the jockey along the potentiometer wire. Then let the balancing length be L2. So this potential difference will be proportional to now L2. In the previous case, with the key in the open condition, proportional to L1. With this key closed, the potential difference is proportional to L2. Now you divide this equation by this equation. This proportional sign can be replaced by an equal sign after writing a constant. Here also replaced by an equal sign after writing a constant. When you divide this equation by this equation, psi and psi will get cancelled. Then when you divide this, it will be R plus R by R. When this is divided by this, psi will get cancelled, and when you divide, this will be R plus R divided by R is equal to L1 by L2. Here proportional sign can be replaced by an equal sign after writing a constant. That constant will get cancelled. That implies R by R is 1 plus R by R is equal to L1 by L2. Take this one to the other side. R by R is equal to L1 by L2 minus 1. From this we can get to the expression for a small r, internal resistance. So L1 minus 1 into L2, L2. So L1 minus L2 divided by L2. Take this R the other side. So small r is equal to L1 minus L2 divided by L2 into R. Using this expression, we can find the internal resistance of this cell. Thank you for watching.